Okay, so our last topic for our unit on biodiversity is ecological succession. This is definitely something that is a common uh, area of questioning in the AP test that you'll be taking next spring. So, ecological succession just refers to a fairly uh, a well-defined succession of organisms that will occupy a given area of land over time after there's been some disruption. So basically, what happens is if there's an alteration in the environment for reasons like, say, a fire or a flood or a volcanic eruption, what's going to happen is there's a fairly well-defined pattern with which a new community of organisms will succeed a following one, and so each new succeeding community is basically outcompeting the one that was there before. And over time, you tend to move from very low growing plants to what we call climax communities, which are often very tall trees in a forest one, but it could also be a grassland or a tundra or a coral reef. It could be anything. But it's this progression from barren, almost lifeless conditions to a very stable system that can last for thousands of years. So we'll divide this into two basic categories. We have what we call primary succession, which is a much longer process, and then secondary succession. So primary succession is basically we have like bare rock, no soil. So we're talking about lava flows, sand dunes, retreating glaciers that have scraped everything down to just about bare rock. Okay. Secondary succession is different because the soil is already established. So we had like a forest fire or a lake fills in with sediment or a tree falls in the forest, leaving this clearing. But the main thing is that the soil and all the nutrients it has are already there. So that's going to accelerate the time period with which we can have the succession of communities occupy this one area of the Earth's surface. So in both cases, though, we're going to start with what we call a pioneer species. So the pioneer species is the first one that's going to occupy the area after the disruption occurs. Now, often when we talk about succession, we're talking about primary succession. I have like a lava flow. The lava cools down. I have this black rock. That black rock can be there for thousands of years with literally nothing growing on it. Eventually, what's going to happen, though, is some small organisms are going to end up growing on there. They're going to end up developing soils, and eventually I'm going to go from these pioneer species to a climax community of some sort. And it all depends on basically the amount of, well, in the case of terrestrial environments, the development of soils. So pioneer species are ones that basically don't require little, if any, soil. So say on bare rock, what we'll find is the first organisms that tend to occupy it will be what we call lichens. Now, a lichen is a symbiotic relationship between, I just realized I often look away from the camera. It's so weird to look at this little dot, but I'm going to try. So a lichen is I did it again, is a symbiotic relationship between algae and fungus. The fungus is able to grab hold of the rock, and the algae is able to undergo photosynthesis. And so basically the two of them work together, and they're able to occupy an area that doesn't have any soils. Now, when they die, when the lichen dies, its nutrients break down, and it slowly starts to build up a layer of organic material that allows other organisms to come and take its place. So we end up with this progression, which we call stages of primary succession. So we start off with just absolutely bare rock. Over the course of hundreds to thousands of years, these lichens will start to build up on here. And what will happen is two things. We'll talk about soils again later in the year, but basically the rock will slowly break up through mechanical, chemical, and biological processes. And organic material will end up being introduced to that soil as a result of the buildup of dead lichens. Now, what happens is that sets the stage for small plants like just little tiny flowering plants, little grasses, whatever, to start to grow. So we basically go from bare rock to lichens to very small. An annual plant is one that just lives for a year, like a grass. Now, what happens though is they tend to make even more nutrients, which allows for longer lasting plants, which we call perennial plants, to live. And so now we get these longer lived perennial plants growing. And then what happens is trees will start to grow because the soil is deep enough that it can support small trees. So small trees start to grow. in the soil, and ones that don't have quite as much in the way of nutrient needs, like, say, pine trees. And then eventually what happens is you get what we call our climax community, and that is in the case of deciduous seasonal forest biome, it would be these tall hardwood trees. And these grow up so high that they outshade these, and then this is what you're left with. And so there's no progression beyond this. Once you reach this, the change stops happening. That's why we call it a climax community. Now, secondary succession is going to happen much more rapidly because the soil is already there. That was the big limiting factor, was these plants need soil. Well, look what happens. I have a forest fire, after which, like they're having in California and Oregon, afterwards, there's just nothing there but dead plant matter. But there's also a lot of nutrients and there's a lot of soil. So again, we'll get these annual plants to grow, we'll get the perennials to grow, we'll get the smaller trees to grow, and we'll get the climax community to grow. The difference is, in this case, it might only take 150 years. In this other one, to get to here, it could take me hundreds of thousands of years, because the hardest part is establishing the soil. Once you've got that soil, you can get from this to this in a matter of a couple centuries. Now, let's see. So basically, the idea is once you get the soil established, small plants start to grow, and then larger plants grow above them, leaving them in the shade. And then taller ones grow above those, leaving those in the shade. So basically, the plants are competing for light by growing taller until you end up with these climax community of trees in a terrestrial biome that can basically outreach everybody else and outshade everybody else. And so basically, there's this almost like an arms race of getting taller until you get to the tallest trees you can get. We call it the climax community. Again, doesn't have to be a forest. We're often talking about forests, but we could be talking about savannas, tundras, whatever. Now, here's a type of secondary succession that's kind of interesting. When ponds dry up, so what happens is, over the course of a pond's life, sediments build up in it. They're quite rich in nutrients. So we call this siltation of the pond. So this, as material builds up, both organic material and silt and sand that gets brought in by periodic flooding of the stream that's the source of the pond, what happens is it eventually completely fills up. The ponds tend to shrink over time until they're completely filled. And now look what I've got. I've got this bed of soil. There's a lot of nutrients. So I get the small plants, I get the perennials, I get the small trees, and eventually I get the climax forest community growing on top of it. But again, keep in mind, a climax community is limited by whatever biome it happens to be in. It could be the tundra, in which case this is the climax community that we're going to get. Could be a rainforest. Could be a grassland or a savanna. It could be any kind of biome. Could be a desert. Now, usually we don't think of succession with deserts. I take that one back. And keep in mind, it's not just the plants we're talking about here, right? It's a community of organisms, which includes the animals that live there. So basically, with each new succession of plant species that are growing, there's a different succession of animal species that can live there. And so we find that it is a progression. Not the plants are the most obvious to our eyes, but there's all the organisms that are supported by those plants as well. And when I was a kid, we'd say, like, well, okay, so the process ends with a climax community, and that could last forever. Well, now we're saying, well, we know enough about the climate to know that nothing lasts forever. As we said in the last slide presentation, there are natural disturbances to ecological systems, and those disruptions tend to, especially climate change, changes the abiotic factors in such a way that these climax communities, for the most part, can't stay forever. Now, one exception is in the equatorial regions. You can have rainforests that lasts almost indefinitely. And it can also happen underwater. So you can talk about the succession in a coral environment. So in any aquatic environment, it applies as well. So there's again a climax community you'll get in any given part of the Earth's surface. So here's how it would work with a shipwreck. So you've got the pioneer species would be like algae, like a ship sinks. Algae, little green algae start to grow on it. And then what will happen is soft coral will attach to that. And then small fish and shrimp will come in, and eventually larger fish. And then we start getting hard corals. And basically hard corals, when we think of like a coral reef, that takes a long time to build. But once we get those hard corals, that's pretty much as far as it goes, and that system can last indefinitely. Okay, so thanks for watching, and that's it for Unit 2. We are done with that one.